So if we recall the graph of y equals sine x, that's not a one-to-one function, because if we think about that graph looking something like this, then we know that y equals sine x is a many-to-one graph, because there's a y value, many y values that are just repeated. So this single y value is repeated for many different x's, so it's many-to-one. On x, therefore it doesn't have an inverse. But if we restrict the domain to be from pi over 2, so if we go from negative pi over 2, and our domain would be restricted to this range, negative pi over 2 to pi over 2, then we do have a one-to-one function, so there is an inverse. So we call that inverse sine inverse, or arcsine. And then if I want to take the derivative, well, I can use our idea of finding the inverse, or rearranging these. So if y is sine inverse of x, then x is sine of y. So I could make this triangle. So if I say sine y is equal to x, that implies that there's a right triangle somewhere with a leg length of x and a hypotenuse of 1. So sine of y is x. This missing side here would be root 1 minus x squared. So I could also find any of my tangent ratios, including cosine, to be root 1 over x squared, or tangent of y would be x over root 1 minus x squared. So if I have it written this way, I can differentiate implicitly with respect to x. So derivative of x is going to be 1. And derivative of sine y, well, that's going to be chain rule. So derivative of sine is cosine of y times derivative of the inside is dy dx. So that means that our derivative is 1 over cos y. But looking here, we said that cosine of y is going to be root 1 minus x squared over 1. So then my arcsine derivative becomes 1 over root 1 minus x squared. If I look in my formula booklet, then that's what I see. So this is given in the formula booklet. We don't have to prove it, but this is where the proof comes. I could do the same thing with my cos inverse. So I could rearrange this to say that x is cosine of y. So that implies this triangle. Again, this opposite side here is 1 minus x squared. So taking the derivative, 1 equals negative sine y times dy dx. The sine of y I can see is root 1 minus x squared over 1. So dy dx is negative 1 over root 1 minus x squared. And if we think about what we know about derivative of cosine is negative sine, derivative of sine is cosine, well, we can see that it's the same thing with a negative sign. We see it in our formula booklet as well. So now let's prove the arctan formula. Again, I'm going to do the same thing, that this implies that there's x equals tan y. Of course, that's x over 1. So if I make my angle y, I've got x over 1. This side is root 1 plus x squared. I know that derivative of tangent, I don't know it actually, I have to look at it, but I can see that it's secant squared. So I get 1 equals secant squared y dy dx. I know secant is 1 over cosine, so this implies that dy dx is going to be equal to cosine of y. Sorry, cosine squared of y. Cosine of y is going to be 1 over 1 plus x, 1 over root 1 plus x squared. When I square that, I'm going to get 1 over 1 plus x squared, which is exactly what I had hoped to get.